All right, just finishing off on the question before. So we were doing the Bézier curves, and so I went through this, and we went through a Desmos example, and then we did this solution from the textbook. Now, I've gone through and I've cleaned it all up, so it's a little bit better here. Now, the second part of the example says find the highest and lowest points on the curve. Now, this is very similar to how we do calculus in that we just need to take the derivative. What we're looking for is we're looking for y of t equals 0 or t equals 0 or t equals 1. Now, this links to our previously in calculus. We've done this in optimization where a max or a min is going to occur when the tangent equals 0. And so that's what we're doing here. And so the idea is that we do the derivative of our y function. So I've got my y function up here. And so let's just do the derivative first. So we get y dash of t is going to equal -4, and then we're going to have 3t squared. And then our next one is -3, and we've got 2t to the 1. And then our next one is plus 6, and t is just the derivative of t is 1, and then plus 0. So this cleans up to be y dash of t equals -12 t squared take 6t plus 6. Now, we're looking at when yt equals 0, so therefore y dash of t equals 0 when -12 t squared -6t plus 6 equals 0. We can divide this all by 6 and we get -2t t plus 1 equals 0. Now, we can do, in this space here, we can do, what am I talking about? Realistically, you can simplify down like this. This doesn't factorize much nicer, so we can use our graphics calculator or a quadratic formula or something here to solve this, and we end up getting, in this space, we get 2t plus 1, 2t minus 1. And then we get a t plus 1 here. I've forgotten a square there. Okay, so our solutions for this particular one equals 0. So this is going to have a solution of t equals 1/2 and t equals -1. Now, you got to remember that t has to be within the domain. So that one can't exist because we've got 0 less than equal to t less than equal to 1. So this provides us with our solution, this t equals 1/2 here. Okay, so what we need to do now is we need to put t equals 1/2 into our formula here for x and y, the x and y coordinate. But just remember t equals 0 is our start point. So we've got 0 and 1. This one here was 3 and 0. So at the moment, pretty well we can guarantee if we get 1/2, it's going to be higher than one of these points because we've actually seen this curve here because we did it in this example up here and we're expecting it to be at this coordinate here. So let's put this in. So if we're going to calculate x of 1/2, because t equals 1/2, we're going to get 3 times t, which is 1/2, which gives us 3 on 2. And then our other value here is going to be y 1/2. And this is going to be equal to -4 over 1/2 cubed minus 3. And then we've got 1/2 squared. What's our next one? Plus 6 times 1/2, and then plus 1. And so this is going to equal negative 4 over 2 to the power of 3 is 8. And then we're going to get minus 3 on 4. And then we're going to get plus 6 on 2 plus 1, which is, let's just go 8 on 8 because that's what we're going to have to go to. So it's going to simplify out to something a bit, and let's actually not do that. Let's change this. Let's halve these, so this becomes negative 2 on 4. This becomes 12 on 4 instead, and then we've got this one here is 4 on 4. Okay, so now we've got common denominators, so we can go here and go, this is going to be negative 2, negative 3, plus 12, plus 4, all over 4. Negative 2 and negative 3 gives us negative 5, plus 4. So we're going to be looking at 9 on 4, which is also equal to 2 and a quarter. Sorry, I've added that up wrong. 16 minus 5 is 11. 11 on 4, which is 2 and 3 quarters. 2 and 3 quarters. Okay, so this coordinate here for this point is going to be 3 on 2 and 2 and 3 quarters. So this is like 1.5. So if we come here back to our graph, we're looking at 1.5, which will be here. And this should be our highest point here, unless I've put my coordinates in wrong, which is a distinct possibility because it doesn't quite look like the highest point. Okay, and that's our highest point. So if I come back down to my solution here, we're going to be looking at this here is our highest point. And then we've got to pick our lowest point, and that is this one here, 3 and 0, which gives us the lowest y coordinate, which this here is the reason that this here is the lowest point. All right, that's it for this one. I'm going to leave it there. Thanks, guys.